This question is related to homothetic and homogeneous functions and also about the MRS of quasi-linear and constant elasticity substitution functions. The question goes like this. A CES, that is constant elasticity substitution utility function, is given as utility is a function of two goods Z1 and Z2 which is equal to 1 upon delta times Z1 raised power delta plus Z2 raised power delta, where Z1 and Z2 are the two goods and delta is less or equal to 1 and delta is not equal to 0. We are being given the CES utility function. Okay. Also, a quasi-linear utility function is given as utility is a function of two goods again, which is equal to twice Z1 plus log of Z2, where Z1 and Z2 are the two goods. Which of the following statements is or not correct? We need to find out. It is a multi-select question and we need to find out the among the given options which statements are not correct. Okay. So first statement is a CES utility function is homothetic, but quasi-linear utility function is not homothetic. Okay. So by homotheticity, what we mean? We know that a function f of xy, so a function f of xy is said to be homothetic. Okay. Homothetic if it is a monotonic transformation of a homogeneous function. Okay. F of xy is homothetic if f of xy is monotonic transformation of homogeneous function. I cannot explain all the things here because I have already made the videos on homothetic and homogeneous functions. Okay. So to give an example, we are saying, let us say f of xy is a function. We say f of xy, it is a homothetic function if it is equal to capital F. Let us say we have a composite function g of x comma y. Okay. I am saying this f of xy is a homothetic function. Okay. If it is a monotonic transformation of another function which is homogeneous. Okay. So g of x is a homogeneous function. F denotes the f, where f is strictly increasing function or monotonic transformation. Okay. So I can explain only this here. Property of homothetic function is, we say a function is homothetic. Rather, we can say every homothetic function is function is homogeneous. Okay. It is one of the property. If a function is homogeneous, it is automatically homothetic function. Okay. So a CES utility function is homothetic. Okay. This function will be homothetic if it is homogeneous function. Okay. So how do we check the homogeneity? So let's take the utility function. Utility, we have the given function, and let us increase both the goods by a factor lambda. So we have u times lambda times z1 comma lambda times z2. Okay. Should be equal to 1 upon delta times, in place of z1 we have lambda times z1 whole raised power delta plus lambda times z2 whole raised power delta, which is equal to 1 upon delta. So let's take lambda common. So we have lambda raised power delta times z1 raised power delta plus lambda raised power delta times z2 raised power delta. We can factor out delta, so we have rather lambda, so we get lambda raised power delta times 1 upon delta, then we get z1 times delta plus z2 times delta, which is equal to lambda raised power delta times the given utility function u of, because this function is again the given function, utility of z1 z2. Okay, so if we are able to factor out lambda, okay, from this equation, so we get a utility function, we get a homogeneous function. Okay, I have explained homogeneity also, I don't have the space and time here. So if we are able to, take lambda common completely from this function, we say the given function is homogeneous of degree n. Here the degree of homogeneity is delta. So this part is correct. A CES utility function is homothetic. What about quasi-linear utility function? So let us see whether the quasi-linear utility function is homothetic or not. So let us increase both z1 and z2 by lambda. So we have lambda times z1 comma lambda times z2 will be equal to twice. In place of z1 we have lambda times z1 plus log of lambda times z2. So can we factor out lambda and lambda here? No, we cannot factor out this because it is with this z2 here. Okay, so if it is not like this, lambda times x plus lambda times y, so we can factor out lambda and we get x plus y. Here we cannot take lambda out completely, so we can say the quasi-linear utility function is not homogeneous. If it is not homogeneous, it is not homothetic. Okay, so this is correct, but we are supposed to find out the incorrect option. Okay, so we are done with the first option. In the second, we are being told if delta is equal to 0, the CS utility function is not strictly convex. Okay, so we have this function. So u of z1 comma z2 is equal to, if delta is equal to 1, so we get 1 upon 1 times z1 raised power 1 plus z2 raised power 1, and we get here z1 plus z2, which is linear function here. Okay, so it is not strictly convex function. This statement is also correct. Now we have the next option, that is the MRS for CS utility function and quasi-linear utility functions are dependent on both z1 and z2. Okay, so let us see. Let us first find out the MRS of this function for what we call it CS production function. So MRS, as we know, it is equal to marginal utility of good 1 upon marginal utility of good 2, which is equal to the partial derivative of utility function with respect to z1, that is mu1, divided by the partial derivative of utility function with respect to good 2. So let's take partials here. So we have 1 upon delta. Okay, so the derivative of z1 raised power delta, it becomes, so we have 1 upon delta, derivative of z1 raised power delta becomes coefficient, then we are left with z1 raised power delta minus 1. Okay, and derivative of this will be obviously 0 because we are taking partials with respect to z1. Symmetrically, du upon dz1 will be 1 upon delta times delta z2 raised power delta minus 1. This gets cancelled, this gets cancelled, so we get z1 upon z2 whole raised power delta minus 1. So MRS is dependent on z1 and z2 for CES utility function. So what about quasi-linear utility function? Let us take its MRS. MRS for quasi-linear utility function, that is del u upon del z1 upon del u upon del z2. Let us take it here. So taking partial with respect to z1, we are left with only 2. Taking partial derivative of with respect to z2 this time, so and derivative of log of z2 is 1 upon Z2. So here we got 2 divided by 1 into Z2 divided by 1. Here MRS depends upon only one good, that is Z2. So this for CS utility function MRS depends on both Z1 and Z2, but for quasi-linear utility function MRS does not dependent on both Z1 and Z2. It only depends on one of the goods, which is Z2 in this case. Okay, so this option, C option, is incorrect. Coming for the last option, that is if Z1 is equal to Z2, MRS is equal to 2. Okay, for both CES and quasi-linear utility function. Let us see for CES. Let us first find out for CS. MRS we have calculated since Z1 is equal to Z2 here. So can we write it here? Z1 upon Z1 raised power delta minus 1. So which is equal to 1 raised power delta minus 1, which is equal to 1. Okay. So for CS production function, if Z1 is equal to Z2, MRS is equal to 1 and not 2, which are being told in the option. For quasi-linear, let us find out. So we got this, if Z1 is equal to Z2, here MRS is equal to twice Z2. Okay, so it is not equal to 2 in either of the cases. So C and D options are incorrect in this question.